Alright, so we're going to learn how to find sine, cosine, and tangent when we're given different information. In other words, not necessarily the angle that it runs through on the unit circle. So notice the unit circle is just this little guy down here. This is your friend, the unit circle. Okay. Centered at the origin, radius 1. But if we are given information about like where the terminal side is headed, right? So like for instance, if you look at A, it's saying that the terminal side is going 6 over, so 1, 2, 3, 4, 5, 6, and 8 down, right there. So that would be the terminal side by doing that. Okay, so here would be our angle. Okay, and it actually does not matter if our angle is this, or going around a whole mess of times. I'm not going to draw it because it's ridiculous. All right? The terminal side is the only thing that determines what sine, cosine, and tangent are. So you might want to pause it right now and read at the top here. Read this. Okay. So basically, you can kind of think of it as SOHCAHTOA. Now, technically, the formulas are these. This is, x is 6, y is -8, and then the radius, okay, we use radius because we can always kind of think of this as being on the circle as that, okay? That's the distance from the origin to the point in the problem. So we have x is 6, y is -8, and r we don't know, but we can use the Pythagorean theorem. All right? So we have r squared equals 6 squared plus -8 squared. R squared equals, well, 36 plus 64, so r equals 10. Okay? I've not left enough space. But the formulas are sine of the angle. So I'm going to say the angle is, well, like I said, it doesn't really matter. It's the angle whose terminal side is going through that diagonal line, so I don't know, whatever that is. Maybe about 200 or 300 and something. Does not matter. Not the point of these. Cosine of the angle equals tangent of the angle equals. Formulas are this. This is what you'll use. Okay? The formulas are these. Sine is, well, it really is opposite over hypotenuse, but in this case we say y over r. Okay? For cosine, it is a lot like adjacent over hypotenuse, but we say x over r. Oops, not y, r. And tangent is y over x. Okay? Sine, cosine, and tangent. Alright? So anyway, that is just y over r is -8 over 10, so -4/5. You should always reduce these. Okay, cosine is 6 over 10, 3 over 5, and the tangent is negative, it's y over x, so it's -6 around here. So you rewrite it. Tangent of theta is y over x. So it's always reduce. All right, another one. But these really are the magic formulas here. These are what you should be thinking of. And the reason why they are different than the formulas in the unit circle is that, well, actually it's a geometry thing. If you drew it out like a similar triangle, you get similar triangles. So this big Y over R, so let's see if I can get the mouse over here. This big Y over here, over, I don't know, say R, for example, would work out to be the same as the little y in the U circle over 1, because it's similar triangles. I'm not going to go into details on that, but that's basically why. Why are we having different formulas? Well, they're different looking, but they will always be equivalent, and the reason is because geometry. All right? So just trust me on that for now. I don't think you want me to go into it. Okay. All right, 0, -5. 0, -5, so that means our terminal side, 0, -5. So there's our terminal side, so this is it right here. Point is 0, -5, and that's x and y. Okay? So actually, that is equivalent or coterminal to a 270-degree angle. So if you know those, because it's one of those are the special ones, actually you don't have to really use the formulas at all here if you don't want to. All right? But what's R going to be? Well, R can always be R squared equals x squared plus y squared. So it's equal to R equals 5. Now, if you look at the geometry of what's going on, yeah, R equals 5. Just look at it. R is the distance from the origin to the special point in the problem. In this case, 0, -5. Okay. So once you have that, you just use the formulas. Sine of the angle is x, y over r plus -1. Okay? Cosine of the angle is 0, or x over r plus 0. And then tangent, they blow your mind. Tangent is, well, hold on, it's y over x. I'm going to write something bad here for a second. Y is -5, x is 0. Can't divide by 0. So I'm not even going to leave this up here because it's so wrong. It's wrong. What is wrong? You can't divide by 0. So you just have to say tangent is undefined. So in your calculators, try to do tangent of 270. It will laugh at you. Do some sort of error method. Right, tangent of angle, that angle, whatever that is, must be undefined. Tangent of 270 degrees is undefined. Tangent of 90 would be undefined for also the same reason. All right, there you go. Last but not least, we'll do this guy today. So -7, 7. Go left 7 and up 7, and that puts you right there. So you have this right here. Okay. You might be able to figure out what that guy is also. But we do r squared equals -7 squared plus 7 squared. All right, it's just like the Pythagorean theorem. This is -7 to the left, positive 7 up. Okay, you don't really need to put the -7 right here. It's kind of silly because when you square something, it becomes positive. But I'm just trying to be consistent with the formula that's in the book where you would always see it. It's r squared equals x squared plus y squared. We do that, r squared equals all that. simplify this. 7 radical 2. Okay, you might have to talk about that more in class. All right, sine the angle is y over r, 7 over 1 over radical 2, and if we rationalize the denominator, we do that, we get it. We're running out of space, let me fix that. Equals 2 over 2. Isn't that special? That's a 135 degree angle. That's the same as a 135 degree angle, by the way. Because that's what that is. Okay? Cosine of theta is almost the exact same thing. It's x over r. So if you think about it, the only difference between sine and cosine here is the sign, S-I-G-N. One is positive, the other is negative. And so you get negative root 2 over 2 is what that would work out to be, because it's the same another problem, only with a negative in there. Last but not least, tangent theta is x over y, excuse me, y over x. So 7 over negative 7, so it's negative. So take 1, 2, boom. So these happen to be special values. It doesn't always work like that. In fact, usually not. All right, so there you go.